All right, so 7-6 is called the inverse of a square matrix. Okay, we're not obviously done with matrices. Both these last sections are still with matrices. This is the inverse. So we're going to learn how to find an inverse, how to make sure something's an inverse, and we're going to learn how to do it with the calculator too, so you can check. So this just says, like, what is an inverse? So if A is a matrix, that is n by n rows and columns, meaning they have to be the same number of rows as columns. So this is a square matrix, like a 2 by 2 or a 3 by 3. Then you can find an inverse, and its name would be the name of the matrix with the little -1 on the side. So if it's A, then the inverse is A to the -1. If it's B, then it's B to the -1. And what happens when you multiply any matrix by its inverse is you get this pattern here. So if I multiply a 2 by 2 and a 2 by 2 together, then my answer is 1, 0, 0, 1. Exactly that. If it's not that, then they are not inverses. So you can see this two different ways. One, you're going to see an example where it literally just says show that A and B are inverses. And then you'll also get one that you can actually, let's say you find the inverse, you could use this method to check it. So this one says if B is an inverse of A, then both A times B and B times A should result in that pattern. Because the order of the letters changes or could change your multiplication, if you are showing that something is an inverse, you have to do both A times B and B times A. So example 1 says show that B is the inverse of A. We're going to do exactly what we just said. We're going to find A times B, and then we're going to find B times A. These are both 2 by 2s, which means that the inverse, that the multiplication can be done. And the result of them are, again, both a 2 by 2. So then we multiply. So if it's A times B, then I do row 1 from A and column 1 from B. 2 times -1 plus -1 times -3. -2 plus 3 is 1. Then I do row 1 times column 2. So I get 2 times -1 plus -1 times -2. -2 plus 2, which is 0. So if at any point in this pattern or in this process I don't get the pattern of 1, 0, 0, 1, then I know they're not inverses. But because this literally said show that it is, we assume that it is. So we assume we already know what our answer should be. Now I go row 2, column 1. So -3 times -1 plus 1 times -3. And I get 3 minus 3, which is 0. And then the last one for A times B would be row 2 times column 2. -3 times -1 plus 1 times -2. And I get 3 minus 2, which is 1. So because it said show, I expected my answer to be this way, but the work is actually the proof here. And again, not only do we do it A times B, but we have to reverse it and do it B times A. For me, because we've trained ourselves to go left and right so much, I have a hard time going right times left. So I will literally rewrite A to the right. You don't have to do this. But my brain, because we've done multiplication so much, my brain goes left then down. Across then down and across then down. And so it's hard to switch it. So I literally just rewrite it. So now first times first would be -2 times, or -1 times 2, -2. Plus -1 times -3, 3, that's the 1. Row 1, column 2, -1 times -1 is 1. Plus -1 times +1, -1, there's my 0. Then I go row 2, column 1, -6 plus 6, there's my 0. And the last one, row 2, column 2, +3 minus 2, there's my 1. So if it said show that it's the inverse, you have to show both A times B and B times A. Good so far?
So not only does it have to be the same, it has to be 1, 0, 0,
Correct. It has to be 1, 0, 0, 1. It's your reduced row echelon form, kind of, the left side of it. Okay. We're not going to work all the way through this, but notice the difference. What's the difference between example 1 and example 2, other than the actual numbers? What got added in here? B has a scalar, okay? So first thing I would do is multiply that in. And then find A times B and B times A. Are you good on the process? Do you need me to work through the multiplication again, or do we feel confident? Okay. So before we did that, we'd have to remultiply it. How about a 3 by 3? How do we feel about multiplying 3 by 3s? Do we feel confident? Yes. So I'm going to have to do A times B, and I'm going to have to do B times A. Now this time, the pattern is, again, the left side of your reduced row echelon, which means it should be 1, 0, 0, 0, 1, 0, 0, 0, 1. For both of these, 1, 0, 0, 0, 1, 0, 0, 0, 1. And I would multiply across and down. So it's just a tedious process, but it's the same process. Do you need me to work all the way through that? No, right? Please, for the love of God, don't do it. Yeah, okay. Questions? The biggest thing is making sure you know that pattern. Okay. Now we're going to find the inverse. There's one way to find the inverse of a 2 by 2 and a 3 by 3. There is 2 ways to find it of the 2 by 2. So I'm going to teach you I would say the choice I wouldn't ever choose again if I had it, because that can only be done with a 3 by 3. And then I'm going to show you a shortcut for the 2 by 2. So this very confusing slide says that let A be a square matrix. So again, it has to be a 2 by 2 or 3 by 3, the same rows as columns. And you're going to write the matrix on this side, and you're going to write the pattern that you want to get, like we just had on the, did I say right side? The matrix goes on the left side, and the goal goes on the right side. So let's say my matrix was 1, 2, 3, 4. Then I would rewrite this as 1, 2, 3, 4. Give yourselves the little dots to know we're separating this out, because that's the original matrix. And on the right-hand side, you're going to write the pattern you're going to try to get, which is 1, 0, 0, 1. Now you're going to use elementary row operations on the entire matrix to get the left side to have the pattern of the right side. So our goal is to either switch rows, add rows, or multiply and add rows, like we did with Gauss-Jordan and Gaussian elimination, to get the left side of this to be 1, 0, 0, 1. When doing that, you're going to be changing the right side. And when you get to your goal, the right side of those colons is your inverse. So I'm going to work through an example. Again, this process works for a 2 by 2 and a 3 by 3. I'm going to teach you a shortcut for the 2 by 2, and then I would never go back. But this you can't do on a 3 by 3. I mean, the shortcut you can't do on a 3 by 3. Okay, so the first thing we're going to do is rewrite this matrix on the left. So 2, -1, -3, 1. And then on the right, the goal, 1, 0, 0, 1. Now my goal is to get the diagonal of ones with the zeros above and below. With a 2 by 2, I would say I don't necessarily always go in the same order. Like your 3 by 3, you always try to get the 1 in the top left. It might be a waste of time here if you can find something else to do. I need a 0 here and a 0 here, and then I can get my 1s. So is there something easy to get right off the bat? The 0 where? In the top right. How do I get that? Add row 1 and row 2. Now I have to add all 4 columns. So I add these together and I get -1, 0, 1, 1. I'm adding all 4 columns. And that we're going to use to replace row 1. So row 1 is now -1, 0, 1, 1. Row 2 is -3, 1, 0, 1. You could put the dots, you could leave them off. It doesn't matter as long as you know that that's the separation. Now I still want 1s here and I still want the 0s here and here. So what's something I could do from here? I can multiply that top by -1. It's going to give me the 1. And the last thing I need is a 0 where the -3 is. How do I get that?
You do the top row times 3 and then add it to the bottom.
Good. 3, row 1 plus row 2. And that replaces my row 2. So 1, 0, -1, -1, 0, 1, -3, -2. The left side is now what I wanted it to be. The right side is now the inverse. So again, I'm going to show you a shortcut, and then I would never go back to this method. But this method is the only method that works on a 3x3. So if you get a 3x3 and it says find the inverse, then you have to do, and it would be a 3x3. So it would be like 1, 2, 3, 4, 5, 6, 7, 8, 9 on this side, and then on the other side 1, 0, 0, 0, 1, 0, 0, 0, 1. And I'd have to go through all my row operations to change the left side into your reduced row echelon form. I'm not going to test you on it, so I'm not even going to work all the way through it. But know that that's how you would have to do a 3x3. Okay? Questions on that method? So this is how you find the inverse of a 2x2. This is a shortcut, okay? And the thing at the bottom is really what we're going to do. Now, this is taught before the determinant, which is why I think it's dumb, because this is really the determinant. So what you're going to do is find the determinant of your, whatever the matrix is that's given to you, your 2x2, and then I put 1 over the determinant times, I switch the 2 here. So if it starts as A, B, C, D like that, I switch A and D, and I change the signs on B and C. So you switch the first and the last, and you change the signs on the second and the third. And then you're going to distribute the determinant into 1 over the determinant into each of those 4 cells. It might sound confusing, but I promise you once you practice this a couple times, it's actually very easy. The only other thing on this slide that's important is that it says that it can't equal 0. If a determinant equals 0, this is undefined, meaning you cannot find the inverse. All right, so now go to example 5. Find the inverse. So first thing we're going to do, find the determinant. We do my little Jesus fish. So 3 times 5 minus 2 times -2. 15 minus a -4 becomes 15 plus 4, or 19. Then I do 1 over 19 times, switch the A and the D, so the first one and the last one. So the 3 comes here and the 5 goes there. And then change the signs on the other 2. So this 2, -2 becomes a +2. This +2 becomes a -2. Now I know that'd be the same as switching them, but you are not switching them. You are changing those signs. And now we distribute the 1 over 19. So 3 over 19, 2 over 19, -2 over 19, and 5 over 19. And that is the inverse of A. So imagine trying to find that doing your, like, Gosh Jordan stuff. You'd have all those fractions in there.
Is that what's going to happen?
No, because you're going to get to use the shortcut.
So we're not going to get a 3x3?
You won't get a 3 by 3. Nope. Questions? You're going to get a 3 by 3, but I'm going to show you how to do it on a calculator. So on the homework, you're going to get 3 by 3, but I'm going to show you how to do it on the calculator. All right, you do it. Actually, but let's. All right, determinant should be 3 times 5 minus negative 4 times 1, or 15 plus 4, which is 19. If it was negative, you would keep it negative. Like this time it's positive, obviously. So was the last time. But if it was negative, you would keep it negative. Then I do 1 over 19 times, switch the 3 and the 5, change the signs on the 1 and the negative 4. So it becomes negative 1 and positive 4. Then distribute it in. It'd be 3 over 19, negative 1 over 19, 4 over 19, and 5 over 19. That's a negative 1. Good? Easy stuff, right? Okay, if you, like I said, if you have your graphing utility, take it out. Okay, first thing we're going to do is actually type in this matrix. So I go to the matrix menu. I go over to edit, make it a 2 by 2, and then type in your matrix. So 5, 1, negative 4, 3. So I put it in A. It doesn't matter where you put it. Just remember where you put it. The matrix menu. So go to matrix and then go over to edit. So second, x negative 1, over to edit. Pick any of them, but I just picked A. And then make it a 2 by 2 and type it in. Then second quit brings you back to your home screen. Go back to that home screen. And then I have to give the name of the matrix. So I go second, matrix. This time under names, I pick A. And then I want to raise it to the negative 1. So right where it says the matrix button, there's a little button that says x negative 1. Just hit that. Or do your little caret and do negative 1. It doesn't matter. It's the same thing. And then hit enter. And then you get ew. All those weird decimals. How do you change decimals to fractions on your calculator? Math. Go to math. And go to arrow fraction. And hit enter. And hit enter again. You won't, but I would say like this is good for checking your work. You would not have them.
What numbers did you use?
I used the ones that I gave you, the 5, 1, negative 4, 3.
Oh, okay. I forgot about that fraction.
So there is one question on the homework that is a 3 by 3, but it says to use your graphing utility. You do not need to go through that big long process. Practice using your graphing utility, okay? Everything else, and this is a short assignment. It's like only like 6 questions. You'll do by hand and you can use the shortcut.